Hi everyone, welcome to the next class, which is remainder theorem, which is the last idea of the chapter D. You need to be very thorough with all the concepts and all the formulae and the specific cases that we have discussed during the concept part. So if you have not done that, I would request you to pause this video, refer that part first, and then come back to the solving of the questions. So let's begin. The first one, typical bread and butter question. Find the remainder when 3 raised to 38 is divided by 244. So we'll need to figure out which power of 3 when divided by 244 will give us the remainder plus 1 or minus 1. So it is the fifth power which gives you 243, and 243 when divided by 244 will give you a remainder of minus 1. So we need to break 38 as a multiple of 5, but it is not the case. So the nearest number of 38, which is multiple of 5, is 35. So let's do the adjustment. 3 raised to 38 can be broken as 3 raised to 5, the whole raised to 7, which is 3 raised to 35, and the remaining 3 raised to 3 besides that. 3 raised to 5 divided by 244, remainder is minus 1. Replace the number by remainder, you get minus 1 as the answer. Right side 3 cube, which is 27. 27 divided by 244, you get the remainder 27. In between there is multiplication, minus 1 into 27. So the final answer is remainder is either minus 27 or the positive remainder will be 244 minus 27. That will give you 217 as the answer. So people usually make the mistake, they get minus 27 and they will mark probably none of these, which is not the case. Whenever you get the negative remainder, I would always suggest to find out positive remainder so that you get the correct answer. If that is also not there, then you mark none of these. That is fine. But without checking first the positive remainder, please don't mark none of these in all these types of questions. Second one, scary looking question. Find the remainder when 38 raised to 16 factorial raised to 1777 is divided by 70. So let's first get rid of the scary power. Let that be m. So now your question is little better looking at least. 38 raised to m divided by 17. What is the remainder? So whenever numerator is bigger than the denominator, always divide the numerator by denominator and you will get 38 divided by 17. Replace the number by remainder. You get 4 as the answer. So now your question changes to 4 raised to m divided by 17. And now that it has converted to R type, we will try to figure out that which power of 4 when divided by 17 will give you a remainder plus or minus 1. So it is 4 square, which is 16, when divided by 17 will give you remainder minus 1. So 4 square, for that adjustment, we will have to write m as m by 2. So 4 square, the whole raised to m by 2 divided by 17. Replace the number by remainder. You get minus 1 raised to m by 2. The whole thing divided by 17. What is the answer? So now only thing for us to figure out is whether this m by 2 is even or odd. Because if this m by 2 is odd, then minus 1 raised to odd will be minus 1. And minus 1 divided by 17, the remainder will also be minus 1. But if this m by 2 is even, then minus 1 raised to even will be even, and I mean minus 1 raised to even will be plus 1, and plus 1 divided by 17, the answer will be plus 1. So if you remember, m was 16 factorial raised to 1777, but we had m by 2 and that whole thing divided by 2, and that is a huge even number. That means now our question is minus 1 raised to even power, which is plus 1, and plus 1 divided by 17. The final answer is plus 1. Option first. Third one, similar background. Get rid of the scary power first, which is m. So question becomes 12369, the whole raised to m divided by 15. What is the remainder? Same funda again. Numerator is bigger than the denominator. divide the numerator by denominator, replace the number by remainder. So when you divide 12369 divided by 15, you get the remainder as 9. So your question becomes 9 raised to m divided by 15. What is the remainder? Now whatever we are going to do is called as pattern finding. Now for this pattern finding, let's consider a few examples. So let's suppose 9 raised to 1, which is 9. When you divide that by 15, you will get the remainder 9. 9 square, 81. 81 divided by 15, remainder will be plus 6. 9 cube, 729 divided by 15, the remainder will be 9. And 9 raised to 4 divided by 15, it will not require rocket science for you to figure out the pattern that the remainder has to be 6. So what you end up observing here is that 9 raised to a odd power when divided by 15 will always give you a remainder of plus 9. But 9 raised to a even power when divided by 15 will always give you a remainder of plus 6. So again here for you to only figure out in our question whether this m is odd or even. And if you remember, this m was what? 1 square plus 2 square plus 3 square so on till 53 square. And to decide whether it is even or odd, we'll need the formula that we have done in C3 operation on numbers, that is sum of the first n squares. So the formula was the biggest formula, n into n plus 1 into 2n plus 1 upon 6. When you apply that, what you end up realizing is the number is odd. You don't need the calculation, or don't find out the actual value. Be smart and reduce the time taken for that calculation. That is odd. That means 9 raised to odd divided by 15. The remainder is 9. That means the answer of this question is also 9, which is option 2. Fourth one. It's a brilliant question because two times we are going to use remainder theorem and last digit and cyclicity as well here. Because in between it turns out to be a different question inside the solution of this main question. You have to find out the remainder when 3 raised to 5 raised to 6 raised to 7 raised to 8 raised to 9 raised to 10. The whole thing is divided by 5. So again, first of all, find out the pattern. 3 raised to 1 divided by 5. Remainder is 3. 3 square, that is 9 divided by 5. Remainder is plus 4. 3 cube, 27 divided by 5. Remainder is 2. And 3 raised to 4, 81 divided by 5. The remainder is plus 1. And 3 raised to 5, that is 243 divided by 5. The remainder is plus 3 again. So what you will observe is that the remainder 3 will repeat after 4 powers. That means the cyclicity of remainder when a power of 3 is divided by 5 is 4. And that is what we are going to do here as well. So now this is going to get converted to a separate question in between altogether. That if you remember, for finding out this answer, what we used to do, that we have covered in the previous class only, divide the big power by the cyclicity of the last digit. So last digit is 3 and 3 ka cyclicity is 4. So divide the power by 4, and hence if you remember, this question now gets converted to a different question of remainder theorem altogether. So now the question is 5 raised to 6 raised to 7 raised to 8 raised to 9 raised to 10. The whole thing is divided by power divided by cyclicity of the last digit, which is 4. To simplify this, what we will do is, again, let the big power be m. Then question is 5 raised to m divided by 4. 5 raised to m, 5 divided by 4, because numerator is bigger than denominator, you get the remainder 1. So the question becomes, I mean, after replacing the number by remainder, the question becomes 1 raised to m divided by 4. 1 raised to anything divided by 4, the answer is 1 only. And that means this last part, the only simplification of power, 5 raised to 6 raised to 7 raised to 8 raised to 9 raised to 10, that answer is 1. That means the question is 3 raised to 1 divided by 5, and 3 raised to 1 divided by 5, the remainder is 3. So don't consider their answer. They have considered the answer as 1, which they were figuring out as this answer. But if you remember, the original question was not this. The original question was this. The one answer is only for the power. So the final question will be 3 raised to 1 divided by 5. 3 raised to 1 divided by 5, we know the remainder is 3. To make a correction here, don't take their answer which is 1. They have incorrectly marked that. Answer is 3 and you need to mark the option accordingly. It is not option 3, answer is 3 for the question. Fifth one, find the remainders when these numbers are divided by 58. So here we'll have to do a cube plus b cube. But while making the groups, make the groups as these ones. So make the first and the last one together and the middle two together. Why so? Because when you apply a cube plus b cube, the first bracket of that is a plus b. And a plus b will be 13 plus 16, which is 29. And 14 plus 15 again, 29. So you can take that 29 common. That's the only reason to make such groups. So when you apply a cube plus b cube, you get a plus b in the first bracket. In the second bracket, a square minus ab plus b square. Same thing will be done for the middle two. A plus b in the first bracket, which is 14 plus 15. And in the second bracket, a square minus ab plus b square. Now after this, what you can do is take 29 common and don't find out any of the values by doing the calculation, but find out the nature of the values. So for example, 13 square 169, which is odd. 13 into 16, which will be an even number. 16 square 256, which is even again. 14 square 196, even again. 14 into 15, even. 15 square 225, even. Sorry, it will be odd. Now when you further simplify the first bracket, odd minus even will be odd, and odd plus even, the final conclusion of the first bracket will be odd. Similarly for the second bracket, even minus even will be even, and even plus odd will be odd. And in between there is a plus sign, so odd plus odd, which will be even. So what are we doing is this entire expression gets converted to 29 into a even number, and which was supposed to be divided by 58. If you remember, 29 twos is 58. That means whenever you multiply 29 with an even number, that is by default going to be a multiple of 58. And when a multiple of 58 is divided by 58, obviously the answer will be, the remainder will be 0. So answer of this question is option 1, which is 0. Sixth one, find the remainder when these numbers are divided by 29. Now here the idea is convert the powers into a same power. So 444 and 333, the common number you can convert the power to is 111. So that means from the first number we'll have to take 4 common. So your question becomes 3 raised to 4, the whole raised to 111. And for the second number, it becomes 4 cube, the whole raised to 111. Now why we did this? Because now when you look at this, it is a question of a raised to n plus b raised to n when n is odd. Again from C3 operation on number, if you use divisibility of algebraic expressions, what you will get is a raised to n plus b raised to n when n is odd, that is of the type a cube plus b cube, and a cube plus b cube is always divisible by a plus b. A plus b will be the factor. So that means this entire expression will be a factor of 3 raised to 4 plus 4 raised to 3. And 3 raised to 4 is 81. 4 raised to 3 is 64. 81 plus 64, 145. And this entire number, which is a multiple of 145, is supposed to be divided by 29. And obviously 145 itself is 29 5s. Yani 145 itself is a multiple of 29. So any multiple of 145, which when divided by 25, will be perfectly divisible always. And that means again in this case, the remainder will be 0. Seventh one, find the remainder when 6 raised to 2013 is divided by 222. Now, here we are going to learn a very important idea that to make the adjustments, sometimes you can cancel some common multiple from both numerator and denominator. So we can cancel 6 from both numerator and denominator. So our question becomes 6 raised to 2012 upon 37. Now this becomes one of our types. Which power of 6 when divided by 37 will give us the remainder plus 1 or minus 1. So it is 6 square, which is 36. So 6 square 36. So break down 2012 as a multiple of 2, which is the case. So our question becomes 6 square the whole raised to 1006 divided by 37. Now 6 square is 36. 36 divided by 37. Remainder is minus 1. So question becomes replace the number by remainder. It becomes minus 1 raised to 1006 divided by even power. Minus 1 raised to a even power. What you get is plus 1 as the answer. And 1 when divided by 37, you will get the remainder as plus 1. But hold on, don't mark that answer because that answer is for the first question 6 raised to 2012 upon 37. We were not supposed to find that. We were supposed to find for the earlier question from which we cancelled out 6 from both numerator and denominator. So to find out the original answer, whatever we have cancelled earlier as a common multiple, we'll need to subtract, we'll need to multiply with that. So 1 into 6, that is going to give us the answer as plus 6. So the property that we are learning here is sometimes for any of the adjustments, if you do this, that cancel out a common multiple from both numerator and denominator, make sure whenever you get the final answer, make sure you multiply back with that multiple that you had cancelled earlier. So that was the learning from this question. Eighth one, last two digits of 2 raised to 100. I'll give you a property for this. Remember this. Last two digits of any number is as good as dividing that number by 100. So this is the thought process you will need to work with. So 2 raised to 100 divide by 100. That will give me last two digits of 2 raised to 100. For any number ka last two digits always divide by 100. For any number ka last three digits always divide by 1000. So this is something that you should try now that we have solving 7-8 questions of remainder theorem. You should at least give it a try. It's a great question. What I'll do is I'll discuss an entirely different thought process, which is sometimes very difficult to strike in the exam in terms of shortcut. So what you can do is 2 raised to 100 can be written as 2 raised to 10 the whole raised to 10. You can see on the right side. 2 raised to 10 is 1024. So question becomes 1024 raised to 10k last two digits. So last two digits are 24. Let's find out the pattern. 24 raised to 1, last two digits 24. 24 square 576, last two digits 76. 24 cube, last two digits will again be 24. So what you realize is that 24 raised to a odd power, the last two digits are always 24, and 24 raised to an even power, the last two digits are always 76. And when you look at this question, 1024 raised to 10, obviously the power is an even power. So that means the last two digits will be 76. So that is the shortcut that you can remember. But again, think from the perspective of the original approach, which is the actual question of remainder theorem. You can see the solution also, but you give it a try to see whether can you get this by trying that approach. Ninth one, again going to tell us a new property. Find the remainder when 6 raised to 152 is divided by 1 is divided by 30. So the property is a raised to p minus 1 upon p, where a and p are co-prime and a is less than p. If these restrictions are satisfied, then the remainder for this expression is 1. Now, how do we first of all understand that? So if you observe our question, p is 31. That means p minus 1 should be 30. Yani 152 ko we have to write it as a multiple of 30, which is not the case. But the nearest number of 152, which is a multiple of 30, is 150. And that is where the adjustment comes into the picture. So the power 152 can be adjusted as 6 raised to 30, the whole raised to 5, into 6 raised to 2, laws of indices purely, the whole thing divided by 31. And now you will see 6 raised to 30 upon 31 is of this type, a raised to p minus 1 upon p, where 6 and 31, a and p are co-prime, and a is less than p. So the answer for that remainder is 1. So left side, your remainder is 1. Right side, you still have 6 square, which is 36. 36 when divided by 31, the remainder will be 5. In between, there is a multiplication. Left side remainder 1, right side remainder 5. 1 into 5. Final answer 5. Option 3. Proper. All these are purely observational skills and the structures. Last one. Find the remainder when 1 factorial plus 2 factorial plus 3 factorial so on till 100 factorial is divided by the product of first 7 natural numbers. Yani divided by 1 into 2 into 3 into 4 into 5 into 6 into 7. These are the first 7 natural numbers, which is as good as 7 factorial. So when you divide this number by 7 factorial, till 7 factorial, everything is fine. And from 8 factorial onwards, I mean 8 factorial, you can write it as 8 into 7 factorial. 9 factorial, you can write it as 9 into 8 into 7 factorial, and so on. So every number from 8 factorial onwards can be written as a multiple of 7 factorial, including 100 factorial itself. So what does that tells us is that from 7 factorial onwards, every number can be written as a multiple of 7 factorial. So you can take 7 factorial common out from those numbers. And when you divide that entire thing by 7 factorial, which is a multiple of 7 factorial, obviously the remainder for that case will be 0. So you need to only calculate the remainder for 1 factorial plus 2 factorial plus 3 factorial, so on till 6 factorial. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 into 2 into 1, which is 6. 4 factorial is 24. In a similar manner, 5 factorial is 120. 6 factorial is 720. When you add all of that, it is 873. 873 when divided by 7 factorial will give you the remainder as 873 only. So right side remainder 0, because all are multiples of 7 factorial. When divided by 7 factorial, completely divisible, remainder 0. Left side 1 factorial से लेके 6 factorial, sum is 873 divided by 7 factorial, remainder is 873. So the final remainder 873, option 4. So folks, what are the learnings from this extremely out of box thought process chapter? Lot of solvings are involved, and there are a lot of different innovative ideas and new ideas that you need to think of when it comes to remainder theorem, and hence you need to be very careful with that. So with this, we are done with remainder theorem, and we are also done with entire D module, which comes under the number system bracket. So chapter C and D comes in the number system. So make sure you revise all of that. If you have any questions, let us know. Thank you so much.